Hey Pranay, thanks a lot for joining us today. Pranay is the lead data scientist at Freshworks, and Pranay has also had an illustrious career both professionally and academically over the last several years. So maybe that's what we'll start talking by. And I know Pranay, you've also prepared like a small case study for us that you're going to present about what a real life problem in data science looks like. And I know that we're going to talk about career advice because you've also built teams, you have hired for data science roles. So, how about we begin with just talking about your background?
Yeah, thanks Akash for giving me the stage. The feeling is mutual. I feel great being here. I'll quickly introduce myself. Right now, I am working as a lead data scientist at Freshworks. I have been in industry for now roughly 5 years. So I am more from a physics background. BS, MS, PhD, everything was in physical science. During PhD, I had to write a lot of code, run certain simulations. And then the results that came out from those programs, I had to analyze them. Some statistical analysis element was present in that. And then during PhD, you have a lot of free time if you do some theoretical work. So I went through artificial intelligence videos and I liked it. By the time I completed PhD, I decided to move to industry, not to continue in academics. So data science was one of the closest thing that I could relate to with my PhD. So it became more and more relevant as the PhD progressed. That is pretty much the motivation for me to get into data science.
Great. And I know it's an interesting decision often for anybody who is doing a PhD whether to go into academia or whether to go into research or whether to go into the industry. What was your motivation for going into the industry and specifically picking what kind of companies or what kind of roles you want to target?
Yeah, mostly the central idea that was in my mind at that time was that I wanted to work more on applied problems. So most of my work had been theoretical. And after doing a lot of theory for last around 5 years, and before that, the coursework, I felt like I want to connect more with the real world problems, something that can make a huge impact in a shorter time. Another motivation I had was whatever work I do should contain some element of programming and some element of mathematical thinking.
Once you did move into data science, how has the experience been? How has the journey been?
Experience has been very good. I have always enjoyed for last 5 years. It is, I would say, very rewarding to work as a data scientist. The best part about industry is that you don't have to be an expert. There is room for everyone, right from beginner to an expert. Someone who can just solve any kind of problem to a person who is just starting out.
Anything you can tell us about particular domains that you've worked in? Because I know that you've worked across
Yeah.
multiple domains and what that experience has been like transferring that knowledge.
Yes, this is the best part about data science. When most of my work has been with traditional machine learning, and that relates to very closely, it is related to statistics. And statistics is something that can be applied in all kinds of problems. So my first job that I did, that was in a startup. It was a food industry, and I was trying to solve a problem where we would look at food recipes and do certain NLP work and convert unstructured data to a structured data. So if you have statement saying in a recipe of some food, let's say you have some ingredient, say one chopped onion, then one should be the quantity, and then chopped should be the ingredient form, onion should be the ingredient. So that is the starting point, one of the interesting problems. From there, I moved to GE Healthcare, where the problem became very serious or very critical. Where I worked on machines like CT scanner, MRI scanner, and we had to predict whether a particular component of a machine is going to fail or not, which component has failed if the machine is down. So that is the kind of problems that I dealt with. Then I moved to ExxonMobil. ExxonMobil is in the business of oil. So there, more or less, the work was related to the plant. So ExxonMobil has their oil processing plants across the world. And so the primary goal was to look at any one particular process and try to optimize it. And to optimize the process, we had to look at the historical data, do some modeling so that we can predict. And if we can predict, then we can optimize the process. So all these huge companies have a lot of complicated process, and these processes have room for optimization. And so this was one of the areas. At ExxonMobil, it was a manufacturing plant. And there was a lot of room for optimization. Recently, I have been working at Freshworks. So again, here I have been working on forecasting. So similar problems are like forecasting the demand as to how many on a given day or in the next 1 month, what can you expect in terms of forecasting, demand forecasting. So
Great. So
yeah,
yeah.
pretty wide range of experience.
So, and how has it been just transferring your knowledge as a data scientist across these domains? Because one of the questions that people ask us often is that what do I need to do to succeed in this domain or that domain? But on the other hand, data science is applicable across so many domains.
Yes, yes. Okay. So this is my opinion, my understanding that I have learned through 5 years of experience and from the academic research also. First thing is people come to data science when the models, the well-established models cannot work. For example, if something can be modeled as a physics model, then it's better to go that way. If something is well established as an engineering work, then it is better to go that way. Data science becomes important when these models, the pre-existing models, they are not good enough. So the domain expert can help you, but he cannot solve the problem. And that is where you don't need to be 100% correct, but a good enough solution is a very good solution. So these are the most rewarding situations. Okay. So to answer your question in short, the answer is as we move to different roles, some amount of domain expertise is required. There are people to help. People from different domains, they will be working with you. They will guide you. And if they are the SMEs, subject matter experts, then ultimately you need to confirm whatever you are doing, whether it is right or not. So a lot of the models that we build today in data science are gray models or black boxes. So it becomes very necessary for us to confirm it with SMEs whether what we have built is correct or not. And especially if you are working with something critical. So critical means a wrong decision can lead to high loss in terms of dollar value or in terms of there are places where there are dangers. So these are the areas where it becomes very important. There are other places where it is not going to make any huge difference. If you are building a recommendation engine, even if you give a wrong recommendation, it does not matter. So there's a pretty wide range of experience.
So I guess there's some of the basic skills that are definitely transferable across domains because they have come to you because they feel that the domain knowledge cannot by itself solve the problem. It requires
Yes.
some data science skills. And then you have
Yes,
to work in partnership with the other
definitely,
stakeholders.
definitely.
Right.
So the core ideas of data science is something that can be applied in a lot of places. And then depending on the problem, you need to learn few things and you need to think how can you model. And in fact, we will go through today, we'll go through one or two instances. How do you convert a real world problem that seems far from data science and that gets converted into a data science problem?
Okay, great. So one other thing I wanted to just chat about was what are some of the tools and libraries that you use on a daily, weekly basis? Because this is one question that we get, like which language should I be learning, Python or R? Which kind of libraries should I be using? So what are some that you use? I know that others may use different ones, but would love to know your stack.
Okay. So right now it has been pretty much standard for me for last 5 years. The programming language has been Python. When I started out, some people were using R, but seems like now it is fading away. There are places huge code base might be in R, but mostly people have started using Python. So if the data is small, whenever we start out, we start with small data. By small, I mean anything that can fit into the memory. So 2 GB, 5 GB, 10 GB, anything less than 16 GB or some whatever your system is. Then you use pandas. Pandas is needed for cleaning the data, doing your slicing and dicing of the data, doing all kinds of ETL. So the core modeling techniques might be utilized there. And then there are a whole lot of libraries that will help you in creating these tables. Then if the data becomes huge, which once you go for mass deployment, then need to use parallelization. So PySpark is used if the data is huge. And then for modeling, again, PySpark has its ML libraries. And for me, I have been mostly dealing with traditional machine learning. So sklearn, scikit-learn has been good enough. I haven't did much with neural networks. So PyTorch, TensorFlow, I haven't experimented with them. But these are the most common tools that data scientists use.
I can see a lot of questions here, but before we take questions, I would love to dig into the presentation that we have of the real life case study.
All right. Let's say we are given 100 rental agreements and we want to extract information from these rental agreements. For example, name of the owner, tenant, what is the tenure of agreement. All these are the problems that we might want to extract. So let's see. This is what the problem looks like. We have these documents. These documents can be 100, it can be thousands, depends on the size of the data. Now, one of the questions is, why would we want to do this? Why would you want to convert this to this? So on one hand, you have natural language, it's written in natural language, and from there you want to extract the details. These details should be in a structured form. Why? Once you put it in a structured form, then you can use all kinds of tools. You can query it, you can use SQL, you can do kinds of extract from load. There are a lot of things that can be done just because it has you have the data of the entire document in a organized way. So the key takeaway or the thing that I wanted to demonstrate today is not any particular technique. The thing that I wanted to demonstrate today is this step, converting problem. When we look at the problem, this one, when we started looking at the problem, let's say this one. Do we see that there is data science in this? Anyone who would look at this would feel that this is something only humans can do. Now, converting it to a data science problem requires us to convert the representation of this problem into a form which can be used by models. The models that we have, that we learn, they are mathematical. They do not understand human language. What they understand is numbers. So what they need is tables, and these tables should have numbers. And based on that, they will operate. So the question is, how do you convert something which is so much different to something that a data science model can understand? So this is the most important step, converting your data into a form which can be used, and further you can extract information. So the problem is this. The problem is written in natural language. Say you might have, there is A who is the owner, and the A has given his real estate on rent to B, and from the date so and so, say from date X to date Y. Okay, so we want to extract this information A, B. But the thing is, on the right hand, when we learn data science, we have models that will take numbers, and these numbers can only predict Y. This Y can be a classification, it can be a regression. So the question is, how do we do this? This is not trivial. But then once you learn natural language processing, you learn that this is not that difficult as we thought it was. So this is how the modeling exercise looks like. First, you extract words. So you convert each sentence into words. Say A is the owner of, say, X, and whatever is the sentence, you take each word. And for each word, what you do is you create features. These features can be anything that can help you decide Y variable. Now, the next step is, what should be the Y variable? So in our case, the Y variable is, we want to recognize entities. So that is called NER, named entity recognition. What we really want to do is, we want to find out what are the elements that are of interest. For example, here A is the named entity. The other person, the owner, the tenant, they will become the named entity. So that is a problem which is called NER. So then how do you convert that to a Y variable? So what you say is, you put A as 1 and the other words as 0. And first step will be just to recognize whether this 1 has occurred or not, whether something is a named entity or not. Once we recognize that it is a named entity, then we can do something else to identify the relation. whether this is a tenant or not. Say there is another named entity B. We want to find the relation, whether this is a tenant or not. So converting the problem from a generic statement to a data science model, in my opinion, is one of the most important technique or most important skill, where you take this and you convert it to this table. So once you have this, then for every word you can put certain features. For every word, whether you can label it by hand, whether something is 1 or a 0. By 1, we would mean that it is a named entity. So it can be a tenant, it can be a owner, it can be tenure, whatever we want to recognize. And then this becomes a classification problem. Once we have done the classification, we have our named entities. Once we have named entities, we can try to identify the relation. Again, that will look similar to these lines. Take the named entity and see if the named entity has certain features nearby it, and then we can try to classify whether it is a tenant or whether it is a owner. So that is how the modeling step goes. And that is what I wanted to demonstrate. This is one example. There are hundreds of examples. So in the interest of time, I'll quickly demonstrate one or two other data science problems. And again, the idea is not today to teach these techniques, but to demonstrate how these generic data science ideas are converted to a problem, they are converted to a form where a machine learning model can recognize it, and then we can keep working to increase the accuracy. So we stop thinking in terms of programs or the instructions that is usually done in traditional programming, and we start thinking in terms of increasing the accuracy, thinking about the features that we should create which can increase the accuracy. So for example, this is one of the problems that in one of my previous job role, this was one of the problems that I faced. There is a machine and we want to identify which part of the machine is going to fail. Now, again, here the modeling step will be, what data do we have available? So you might have some logs which is generated by machine. Maybe the machine consumes certain electricity or certain things which are measured by certain sensors. So then that is that you have. And then looking at that, your y variable will become what is the part that you want to say has failed. So say there are 4 parts, part 1, 2, 3, 4, and then given certain data, if say part 1 has failed, then we can label the data and present it in the form of a table. And once we do this, this problem is converted to a classification problem. So again, here, these are not all the details. Put in all the details, we would need to specify what the data looks like. We would need to understand how should we present it in the form of a y variable and an x variable, and how can these x variable actually help in determining y. So for example, if y variable is the part number, the part which is going to fail, there should be something hidden in x that should signify that, okay, this part is going to fail. If the x variable, say voltage or current or the machine sensors might be, if they do not have that signature, then it is impossible to identify the y variable. So that is, I think most people call it as garbage in, garbage out. So if you do not have x variables that can actually predict y, you just cannot predict it. So whatever predictions are being given, they will be random, more of a coin flip, and the accuracy will be low. So this is one of the problem statements. Another problem statement can be, say, when I was working in the oil industry, then there was a huge plant that was running, and under what conditions should the plant run so that the operation minimizes waste and maximizes the efficiency. So again, this is a human statement, problem statement. Now, converting it to a data science problem requires you to first look at the data, see what the data, whether the data has enough information or not. And then the next step is obviously to model it. So when you are modeling it, you should have your y variable. That y variable should be something that can determine what is a waste. So for example, if we want to find out under what conditions we can minimize the waste. So why should we model it as, let's change the problem statement a little bit. Let's try to model the waste. So let's make y variable as the waste. Okay. So say for example, in oil, a certain chemical, say chemical X, that is a waste product. And we know that we can minimize this waste. Okay. So then the amount of waste that is being produced by the plant, that will become our Y variable. And the X variables will become the conditions which determine the conditions that are going to affect the increase or decrease of this waste product. So there should be certain variables which at least affects. It need not be monotonic. It need not have a trend which is obvious to, say, the chemical engineer, but it should have some causal relation that changing this particular variable, say temperature or pressure or some chemical which is added to the system, should change Y variable. It should either increase it or decrease it. So then in that case, we can model this. And once we start modeling this, then there are a whole lot of techniques. You can model it with regression. Inside regression, there are, depending on how you want to model, how much data availability is there, you can decide what techniques to choose. Another one, third one, is that thing that I'm working on these days. So this is forecasting, demand forecasting. For example, you see that every day, imagine that we are sitting in a particular shop and we see that the demand goes up in certain season and then it comes down. So now the question might be, can we do something? Can we take this data, historical data, which says demand? So this is demand on y-axis, and on x-axis it is time. And the question is, can you look at the data and help in optimizing the business, in increasing the profits? So the answer is yes. If there is enough data, we can do it. We just need to find out, one, if we do not have enough data, look at the last 30 days. And in these last 30 days, there will be certain trends. Maybe certain things that you are selling, its demand is increasing. So if you can identify some monotonicity in the data, then you can predict that, okay, on an average, we can expect the demand to go up. If there is some, if you have huge data, say like last 5 years of data or 3 years, 10 years of data, then you might have certain seasonality in the data. You can say that in a particular month, maybe this is a festive season, and we have seen that every festive season, there is an increase in demand. And so you can try to create a model that can try to predict that, okay, this particular month has come, we can expect certain increase in the demand. So this is one of the problems that can be solved with data science. This is just for people who would want to get into details. This is time series modeling. This is one way to model it, time series. So again, here we look at the data, and this data needs to be converted into a form which can be used by a machine learning model or a time series model. So there we look at the data, we convert it again to a form which is your X variable and a Y variable, and somehow you use X variable to predict Y variable. Now, how do we do that? That depends on the techniques you use, and that is where the depth in the machine learning model comes in. The more detailed knowledge you have about these techniques, more will you be able to determine that, okay, this is the particular technique that will be useful for this particular problem. Okay. The overall point that I'm trying to make is, when having a depth in mathematical depth into these models is going to help you in determining how to model. And the conversion of this particular statement into a data science problem, that is one of the huge step. And then the second step is the math part, the analysis, the mathematical part, where you know that, okay, this is what I need to do to optimize the system, to increase the accuracy of the system. So pretty much this is all what I had. This is one of the topics that I found over years was pretty interesting to me, that just by doing certain change of variables, certain changes in the data, I was able to model it as a data science problem. And then it became either a regression problem, either a classification problem, and we could do it. And then the problem obviously then boils down to increasing the accuracy, making it better, making the modeling or feature engineering. That is the next step.
Great. Thanks for that presentation, Pranay. It was really insightful. One question that I had when I was watching this was, how does one cultivate this skill? Like, is there any way to understand how to formulate a problem as a data science, formulate a business problem as a data science problem?
There are two things. One is try to practice, try to solve as many problems as you can when any student or any learner who is going through the coursework, they watch these course videos and try to solve certain boot camp, certain problems. And the other thing is experience. Once you actually start solving problems in industry, then you are stuck with a problem for at least 3 months, 2 to 3 months. And that is where you keep thinking and you keep talking to people, how should I model it? And over years, you develop this skill. So there is no single answer to it. To some people, it is very obvious. I struggled with it for a long time, and that is why I presented it today.
I think it's definitely a very useful thing for people to understand the importance of just formulating the problem, because we look at Kaggle datasets which are nicely formatted as CSV files already, and we feel that this is how the data is going to come. I think the second point is about signal. How do you know if there is enough signal in the input variables to determine the target, and what do you do if you cannot find enough signal? How do you approach this?
Yeah, so this is my approach. You start with some data. If the data is simple enough, in some cases it is. Many problems that you will encounter will be simple enough. By simple, I mean there aren't a lot of variables that are going to affect Y variable. So in that case, you can actually do some very simple statistical analysis. You can try to see correlations. You can try to plot the data. You can do some dimensionality reduction techniques. Those things you can do to check whether there is a signal. Other thing comes from intuition sometimes. So for example, if I want to find out whether a particular word is a named entity or not, then we know certain features are going to signal that. For example, a word starting with a capital letter, it increases the probability that this word might be a noun. This word might be a named entity. So some of the things are very obvious. In some of the places, there is ambiguity. And so you try out different things, you experiment with it, you try different features, different models. And then if for a very long time, say you have spent 2 to 3 months and there is no success, I usually say it is better to close the project than to just keep dragging it for a very long time. So if something is going to fail, better fail fast. So that in industry, there are a lot of problems to solve. So even if you fail at one project, it is not going to make any difference to the company or the person who is working with you. He will have hundreds of problems. So better inform them that I don't see much promise in this particular problem. Let's change the problem. Let's work on something else, something that will give more impact.
Makes sense. Well, I want to ask one last question before we talk about career advice and the hiring process and things like that. Now, you just talked about this example of defining the problem, kind of looking at the data and then modeling. A lot of people have this question: what does the breakdown of time look like over the course of, let's say, a 3-month project? And because a lot of people tend to think, can we jump straight to a machine learning, or what exactly does that breakdown look like? So just from your experience, having worked on so many different problems, what does that look like for you, different stages of the project?
Okay, it varies a lot. There is no single answer to it. There will be cases where you will get data coming from engineering. So there will be certain sensors that will be producing data, in which case a part of the work is easy. You don't need to make a lot of change. In that case, the cleaning up is the only time that you will take. So pre-processing. So in that case, modeling all the analysis will range from somewhere from 3 months to 4 months. There will be cases where the data is very dirty. You do not even know how to represent it in a mathematical form. How do you represent it in numbers? So in those cases, the project can go pretty long. People can spend 2 months just trying to clean up the data, trying to make a data something that the model can work on. Okay. Typical data science project can range anywhere from 1 month to a year. And sometimes if the problem is very challenging, it can go for multiple years also. I will be surprised.
That's very interesting to hear. Okay, so maybe let's switch gears now. And I know a lot of people have questions about just getting into data science and what that process looks like. So what would be your advice to the people on this call? A lot of them are either students or are working in some other role and have been learning data science on the side and are trying to break into this domain.
Okay. So this is my advice for students or learners, people who want to get into data science. One thing is, first of all, have faith in yourself. There is place for Okay, do not think that you won't get a job. I have interviewed people who were at a beginner stage where they had some basic knowledge of data science to the point. I have interviewed till intermediate, and then there are experts. So I haven't interviewed for expert level of hiring, but there are people who are just experts in their domain. You throw a problem at them and they will model it, they will produce a solution. So for students, I would say when you are learning, do not get disheartened. Things are, especially when you're learning. So this is my quotation from, I'm quoting one of my professors. What he said is, learning is a very slow and painful process. So when you learn, there will be days where you will feel that it is not possible. It is very difficult. Just go through it. Keep working towards it. Get your basics right. Get as much, at least the basic mathematical foundation, if you can build, it'd be great. Then spend some time writing the program. It is not good enough to have theoretical knowledge. At least write one project, work on at least one project, have some experience in programming. So you should, these are good to have things. More better it is. So better to know SQL. Definitely learn about Panda, learn something about Matplotlib or any particular plotting software. Okay. Then other thing is, this is something to either that is to be acquired during the job, or maybe if you can do it beforehand, learn to communicate. After becoming a data scientist in the job, you will often see you will be dealing with people who are not mathematically sound or technically sound. So at least in data science, they are not technically sound. So in that case, you need to explain them in simple words, what is it that you're doing or what the accuracy means. So you cannot throw at them certain graphs and say, okay, this is the precision, this is the recall. Do not talk in technical terms. Try to simplify it for them. That helps. The other thing is, always keep learning. The biggest problem with data science is it is evolving and new things come up every day. So, like recently, there has been a huge discussion about Chat GPT, and all of a sudden now reinforcement learning seems to be the way to go ahead. So always keep learning. Do not stop. Once you become a data scientist, does not mean that it is the end of learning. Bootcamp is not the end; it is a beginning. Okay, so keep learning, and then no course is going to cover all the topics. So you can expect a lot of things to learn during the experience, during your job in industry. That is where a lot of things, when you spend a month trying to think about the problem, trying to search for techniques that can help you solve the problem, that is where a lot of things will get clarified. A lot of times you will have deja vu that, okay, this is what I learned way back. Okay, this is here, it makes sense. So those kinds of days will be there. Yeah. So
Great.
that,
That is, I think that is wonderful advice. And I know that you've hired, as you mentioned, for various levels. And I want to talk to you maybe specifically about hiring freshers. And I think one of the things that people struggle with is they don't hear enough from the recruiters or people hiring what they need, what they're looking for, right? So I would love to hear from you when you are interviewing somebody who does not have any experience in data science, who's maybe for a fresher role in data science, like a junior data scientist. What is it that you look for specifically?
yeah. So when we are hiring freshers, we don't look for experts. We are not looking that the person whom we are interviewing should know everything. They should know one thing, any one thing that they have worked on. If it's a classification problem, they should have worked on it in depth. They should be able to distinguish what is a good model, what is a bad model. Okay, how to evaluate the performance of a model. So you need not learn deep learning plus some classification problem plus some regression problem plus some NLP and computer vision. No need to do all of it. Do one thing, but that one thing should demonstrate. So the thing is, in industry or in any place, the person who is interviewing, by the end of the day, he has a time crunch. He also is an employee who wants to just hire and is looking some way to evaluate how good is the candidate. So how would they judge whether a candidate is good or not? The only way to judge is you start discussion in one particular area and try to demonstrate that yes, you have spent enough time to do a critical thinking, and given a new problem, you'll be able to justify the problem. That is good enough. That is at least what I follow. Okay, again, interviewers vary a lot. There is a huge variation among interviewers. Some look for breadth, some look for depth. So I usually follow this. I usually look for one particular topic in which the person has worked on, and he should be able to do at least the basics. He should be able to take the data, transform it in a way that it can be modeled, and then once the model has been created, some evaluation should be there. How good was the model? That is all.
So, good understanding of the basics and having worked deeply in one specific area, maybe having one good project
Yeah.
that they can talk about. Great. And I also want to ask the other side of the question, what are some common mistakes that you see people making in interviews?
So different people make different kinds of mistake. So for example, they may not have worked on a particular problem, but because it is in fashion, people have heard about it, they will do some very basic superficial work and they will mention it. Once we get into the depths of it. So this is one of the most common mistake that I found during interviews. You have written something in your CV, and then I start looking at that and start questioning something. And then in the middle, so for example, candidate mentions that the person has done some CUDA programming. And I start questioning one or two things from CUDA programming, very basic stuff. And then the person says that, no, this was a common project someone else had implemented. I have not worked on it. So that I have just 1 hour to evaluate the person. And in that 1 hour, in the beginning, if something comes up, or in the middle, if something comes up, which makes me think that I cannot trust the CV, most of the things that are written in the CV is wrong, then that puts a bad impression on the interviewer. Then maybe a lot of things that I'm reading and I might be impressed with does not look impressive anymore. So I would say not to inflate your CV a lot. Mention things that you can answer. You never know who would look at what part of the CV and try to get into the depth of it. So you should be able to justify whatever you write in your CV.
Makes sense.
Yeah.
All right. Well, those are all the questions I had, and but we have a lot of questions from the participants as well. Thank you all for posting all these questions. I think we'll try and take a few questions. We have about 5 minutes or so. So let's begin. Maybe we'll take like one career related, one technical question so that we can balance it out. So here's the first thing that people have asked. How to learn advanced mathematics as a college student to pursue a data science career?
If you are a college student, it is a very good news. You have a lot of time to pursue these things. So back then, when I was a student, I used to follow courseware. So I followed IT Open Courseware. They have pretty good lectures. So for data science, I would say go ahead with the linear algebra. Then try to have some basic knowledge of multivariable calculus. You should know what is a gradient, because you will be using gradient descent and all. So a basic understanding of these topics, calculus, multivariable calculus, not the ultimate of it. I, being a physicist, had gone into other depths of it, but at least have some basic understanding of what is a gradient and all. Have a good understanding of statistics. There are very good lectures for statistics. And then, if time permits, definitely do some specialization. Do courses in natural language processing. Do courses in as many as you can. So the best part about being in college is that you have 3 to 4 years. So you can try to gain both depth and breadth. The thing that becomes little difficult when once people are in industry, either we gain depth, or if we switch projects a lot, then we gain breadth. So yeah.
Fair enough. And one thing I also want to maybe touch on here is like how much should you balance learning theory versus building projects? What is the or what how to find the right balance?
Again, that varies a lot. So I used to believe that you should be having a lot of time spent on theory. But after coming to industry, my experiences tell me that not always having that depth is going to make you move forward fast. So I would say somewhere little more than 50% should be the weightage on theory, but then say 60-40, 70-30. So spend fair amount of time trying to build projects, trying to see how it can be applied.
Fair enough. One question here is, how do you make a transition to data science if you have been working for 10 years in a different career? This is a common question that we get.
The problem that you will face when switching from a 10-year experience is the mostly it will be more on the compensation part. The problem is, again, we have interviewed people who were from very different background. The problem is that once a person has certain number of years of experience, then the expectation on the salary part is high. But on the data science end, the experience is not that high. So that is the dilemma that companies or most of the interviewers face. Okay, if you are willing to work, I don't mean you, I mean the person who is interviewing. If that person is willing to work for a low compensation, I don't think there will be any hurdle. Initially, that will be a hurdle, but once you get into data science, try interviewing in different companies, try going for startups where you would always add value. And in startups, there is always a crunch for either talent or the crunch for on the compensation part. So there, definitely you will get opportunities. Once you are in the system, once you gain experience, then you switch and ask for higher compensation. Definitely you will get it. Whatever is your worth, definitely you will get it.
Makes sense. So early on, you can't optimize both for compensation and for the switch. I guess it makes sense to switch first and then go and prove yourself, and then definitely there's so much opportunity in data science. Right?
Exactly. So again, the same problem is faced by the interviewer. How would a person judge whether the person who is being interviewed, whether that person is good or not? Right. We have just 1 hour to 2 hours at max.
Okay, next I can see a question here regarding the presentation. So the question is, how do you optimize two target variables in parallel? For example, somebody has said maximize efficiency and minimize waste.
Okay, so that is a modeling question. Okay, I won't have a offhand answer to that. Right. These things usually start. So a lot depends on what data do you have available. Are they highly dependent on it or not? Okay. I do not have a offhand answer.
Fair enough. Yeah, I think we'll have to look at a very specific case to decide that.
Okay.
Okay, what can I see? Yeah, this is a common question. This is a popular question we get. Will AutoML or SageMaker ML make data scientists, ML engineers redundant?
No, never. No technique or no AI is going to make a technical job obsolete. Okay, that is my take on it. This is my opinion. No matter what AI systems you build, these AI systems can do after you have modeled, after you have created these features, they can run certain number of experiments. They can try to optimize the parameters. Something that can be optimized will be optimized. So I always take this example. I was working on a particular project and there we had certain data. If subject matter experts were not with us, we wouldn't know that a particular variable that we are looking at, that in itself does not have any meaning. We need to convert it to its hexadecimal representation. And then in that there are certain bits. Those bits are the important ones. And so we extracted features out from those bits. And that is what became the feature on which the machine learning model would operate. Now, without the knowledge of SMEs, how would a machine learning model know that this data has to be converted into a hexadecimal and only certain bits are important? So you need the ideas from SMEs, you need the ideas from data scientists, how to model it. You have the data, but now it has to be presented in a particular form so that the machine learning model can take and learn on it. Okay. So the feature engineering part has to be done by data scientists. Now, there are places where the model can create certain number of features. But again, what features are relevant? As you expand your feature set, the problem becomes more and more difficult to solve. So if you want a lightweight model, then it is better to hire someone who will spend and put intellect into it and create a model, something that cannot be done by machine. So I wouldn't say AutoML or any particular library is going to make these jobs obsolete. These jobs are not going anywhere. What it will do is it will make our life easier. We don't need to do a lot of coding ourselves. Maybe we can create the features, hand it over to AIML, the auto ML, and it will run certain experiments and it will give us the results. Now we should have capability enough to interpret these results to find out whatever we are getting is not garbage.
Right. Yeah, I think at least so far, we don't have a replacement for human insight and human ingenuity. Some of these automated processes can be optimized, but I guess this piece is going to be required.
I believe human ingenuity or this creative part of
Right.
humans, if we want to get that done automatically, that would require some breakthrough in biology. It is not a problem that needs to be solved from physics or computer science end or from a mathematical end. That requires to understand the process of evolution, how we got our intellect, from where is it coming. So
Yeah.
that is my belief.
That's an interesting take, especially given a lot of conversations happening around artificial general intelligence. That the human intelligence has evolved in through a certain path over millions of years, and how far can we get without maybe going down that path and going down the biology itself? Yeah.
So another thing is most of the data science depends on data. For example, ChatGPT depends on the data on which it is trained. So it can be only as good as the data it is provided with. One of the shortcomings I was reading about ChatGPT is that wherever the number of data instances is less than 10,000, ChatGPT does not perform very well. So imagine a person trying to work in an area which is little novel, which is very specific to a particular use case. You're not going to get data corresponding to it in real world. So in that case, no machine learning model or auto ML or any algorithm is going to solve the problem. It requires critical analysis. And for that to be automated, you need certain breakthrough in biology, I believe.
Fair enough. So maybe last two or three questions I want to cover, Pranay. One is around the skills. I think somebody asked a question around two areas. One is like how deep do you need to go in your knowledge of Python and SQL is one. The other was that how much knowledge of ML ops and deployment and such things would be required.
The answer is better is always more is better. So there is no one answer to it. I would say at least have basic understanding of SQL, basics in Python to start with. But yes, having more knowledge always helps. So if you have knowledge of object-oriented programming, if you can program better in Python, you will structure your code properly. But that does not mean not having it will make you a terrible data scientist. At least you can get started on the way, and then you can learn these things. The same goes for SQL, same goes for other topics as well. More you know, better it is.
Fair enough. And I guess it's also a process of like iterating. You keep learning as you work on more projects.
Definitely. So, for example, SQL is something that initially you may not feel very motivated to learn, but at least learn the basics. Once you start working with huge data sets, then you'll come across PySpark. And that is where your interest in SQL will go up. So yes, as time progresses, a lot of things you will redo, read again, get detailed knowledge, become an expert. That is the process of learning.
Okay. One other question here, career related, is do you need a computer science or engineering degree to be good at data science and to get a job? Or what are the educational requirements that you would normally look for?
We have not looked at any particular educational qualification. Mostly in data science, people prefer masters, but again, that is not a necessary condition. Having a bachelor's degree is good enough. I myself am from a physics background, which at least back then was not related to data science. There was intersection between the two, but again, it was not something that data scientists would be studying. So mostly what you need to know is some knowledge of statistics, some knowledge of programming, things that I mentioned earlier on. So some ideas of machine learning, how to evaluate a model, all those things. And then obviously if anyone has better knowledge of NLP or any specialized area, for example, computer vision, that helps. So degree wise, I don't think there is any particular degree, at least as of now, people have not looked at degrees. The reason being people who are working in industry, in data science, they are coming from a wide variety of background. And there used to be a time when we felt that maybe getting a particular Udemy or Coursera or a particular degree from some certificate from a particular area is helpful. But then the thing is, nobody looks at the certificate. What they look for is whether the person has worked in this thing or not. Is the person knowledgeable or not? So more and more, as time is progressing, I feel interview is becoming more and more important than a particular degree.
Right. Yeah, I think having good projects that you can show people, that you can talk about, as you mentioned, in depth, I think that probably means a lot more than any degree or any certificate you have listed.
Right. Exactly. The thing is,
Okay. Yeah.
even degrees, some of the degrees people can just copy paste and get the certificates.
Yeah.
So that is again a problem. No one can
Yeah.
post a particular certificate.
Yeah, especially with so much moving online, really the only way to test, I feel, to test somebody's understanding of subject is to talk to them and ask them some hard questions, kind of probe deep, right?
Yeah.
Yeah. Okay, I think we'll take one last question. I know we're over time, but the question is related to one of the things that you mentioned about timelines of projects. How do you not give up if you're working for a certain problem, on a certain problem for multiple quarters or for even close to a year? What are some signals to keep going or to stop?
You would know when to not give up. You would always have that intuition. If you feel that there are certain things that certain new things that you can add to the project which can increase the accuracy, the experiment can fail. So again, as I mentioned earlier, if you do not have any hope, if you have done all your experiments, if the data that you have does not look promising, then it is better to end the project. So recently, okay, I'll share my screen and explain this particular part. Okay, let me explain this on the whiteboard. So, for example, forget about data science. In data science, we deal with a lot of features and a lot of, there are a huge number of features. But let's consider just two variables, x1, x2, and y. Okay. So let's say you have two features, x1, x2, and then y variable. And this is what you want to predict. Okay. So if this is your x1 and x2, and then what you want to really predict is just a y variable, then this is something that you can predict. Now the data should look like this. What if the data that has been given to you that has a lot of noise? You get a lot of points in this area. So for a given value of x1, x2, what if you have these many y values for the same x1, x2? So the input remains same and the y variable is changing a lot in different rows. Then this is what we call as irreducible error, something that cannot be reduced and cannot be modeled. With the data that has been given, maybe there were more number of features that would change, that would help us in determining this noise. So as long as we have this data, only two variables, and we are working with these two variables to predict y, this is the part you cannot get away with. So in this case, it is better to give up and stop the project. But now, all of a sudden, you feel that, okay, we have missed something. The problem statement to the stakeholder who has given the problem statement, they came up with some new variable x3. And this new x3 now will help us in changing this. So maybe this was not, this x3 creates these different planes. And for a particular value of x3, say x31, x32, these are different variables of x3. Okay. So now with the presence of this one new variable, now you can actually model this y. So with this, you can try to predict with better accuracy what is the y variable that you are going to look at. Then this becomes solvable. So from the diagram or from the explanation, what I want to mention is, when you see, when you are solving a project, if you see promise enough that, okay, going forward, I'll add these many features and these features are going to help me predict my y variable, maybe help in doing some classification, some regression, whatever is the problem, then you keep dragging the project. If you do not see any hope, no new features are coming in, you have done all your experiments, it is better to end. So that is how I have decided to either stop a project or to keep moving forward.
Great, thanks. I think that was actually really insightful just seeing that visually, that the irreducible error and how a single new feature can completely change. And sometimes I think sometimes something that people miss is that instead of going after training multiple machine learning models, making them bigger and bigger, just searching for a new feature can completely give you a step change in the accuracies that you can get. Data science in the real world is just so interesting with all of these subtleties. And of course, the whole process of like working with cleaning data, working with other stakeholders, explaining things in simple terms, explaining why the model is giving. It is just such an exciting journey, and you can probably spend years while working just continuing to improve and continuing to learn. Right?
I agree. Yeah.
Perfect. Well, I think we will close at this point. So, Pranay, thank you so much for joining us. Thank you so much for talking about your experience, talking about how you look at data science problems, how you formulate them, and also sharing so much career advice and also so much interview advice.
Thank you. Thanks to everyone for listening to me. And yeah, thanks for the platform, Akash. It was great being here.